Student, today we are going to learn sound wave, okay, which is going to be continuation of waves. It is for class 11, okay. So sound wave. So in this video we are going to discuss what is the properties of the sound, what are the factors affecting the sound, how the sound wave getting reflected, and also how the sound wave getting refracted, okay. The properties of the sound we are going to discuss. The first one, properties of the sound wave. So first one, properties of the sound wave. Sound wave property. Sound wave will travel 330 meter per second at normal temperature pressure in India. Okay. So it is not required the medium, which is not required the medium, which is required the medium. Required medium. If you want to, if the sound will be travel only in a medium. Okay. So it's required, definitely it's required the medium. So light wave is not required medium. Okay. So sound wave, which is going to be called as the longitudinal wave. So longitudinal wave will be produced as a compression, rarefaction, like that. Compression, then rarefaction. Like a spring, I am taken example. So when the sound wave is traveling, all the particle will be getting compressed, then rarefaction. Okay, so more compression will be there when the loudspeaker produce the sound. Okay, so compression, rarefaction, like that only sound wave will get travel. It is called mechanical wave, which we are going to call as the mechanical wave. Compression, rarefaction, the point will get compression, rarefaction, like that sound wave will get travel. So sound wave velocity is equal to wavelength into frequency, okay, and it is required the medium. The second one, what are the factors affecting the sound wave? Okay, so factors affecting the sound wave. So we are going to discuss totally is the 5 factors. Okay, one is pressure, another one is the temperature, another one is the density, another one is the humidity, another one is the wind direction. Okay, these are the topics we are going to discuss. Okay, first we will see how it's going to affect with the pressure. Okay, actually the sound wave pressure is getting independent. Okay, it's not affected with the sound wave which is going to be independent. If the pressure is increased, the sound wave is not going to affect. Okay, so because now we are discussing how the factors is affecting with the pressure. Its velocity is equal to root of pressure by density. Velocity is directly proportional to the pressure. Okay, pressure by density 1, pressure by density 2, pressure by density 3 is going to be the constant. Whatever you are taken, when the pressure is changing, density also is going to affect. Okay, that means pressure is not going to affect the sound wave. It's not depend on the pressure is not depend on the, it's not going to affect the sound wave. Okay, next, temperature. I am going to tell you how the temperature is going to affect. Velocity is equal to root of pressure by density. Okay, we know PV is equal to mu times of RT. So P is equal to mu times of RT divided by V. So small v is the velocity, capital V is for the volume. Okay, so instead of writing P, we can write this equation root of mu RT divided by V density. So velocity of the sound wave is directly proportional to square root of temperature. So temperature and velocity is directly depends. More temperature have more velocity, less temperature have less velocity. Okay, if the atmosphere have more velocity, more temperature, the sound velocity will be more. Okay, so velocity is directly proportional to squaring of temperature. The next one, density. So density, how it's going to get affected. So we know already velocity is inversely proportional to root of density. Very simple equation. So when the velocity density is more, velocity will be less. When the density is less, velocity will be more. Very simple. So velocity is inversely proportional to root of density. So density is going to affect with inversely proportional. Okay, then humidity. In morning time you can hear the sound. Somewhere if the sound is some festival or something is there, means long distance sound also you are able to hear, because of humidity get changed. Okay, in morning time the atmosphere will be more cold. Okay, so more cold we can have less density. Okay, because dry air compared to the humidity air will have the more denser. Okay, dry air have more denser compared to the like a morning the cold atmosphere air. Okay, humidity air. Okay, so this is what we can come to know. Okay, see here, more humidity, so like that means it's in morning time more humidity have it is a less density. Okay, when the less density is there, density is inversely proportional to velocity, will get velocity of the sound will be more. That is the reason morning time you are able to hear the sound, a long distance sound also. Okay, sorry, early morning I am talking. Okay, approximately 4 5 6 like that. Okay, then drier, it's a less humidity. When the less humidity is there, it's going to be drier, the density of the drier will be it's more, that means velocity will be less. So you are not able to hear the sound at noon time or 10 a.m. or 11 a.m. like that. Okay, because the humidity is not available. Okay, so this what is going to happen. The next thing, wind direction. So this side is wind direction, means the person who is that side able to hear the sound. If wind direction is this side, means the person will be this side is able to hear the sound. Okay, I'll repeat again. There are 5 factors: pressure, temperature, density, humidity, wind direction. Pressure is independent. Okay, pressure is not dependent. It's not going to affect the sound wave. The temperature is directly proportional. Velocity is directly proportional to root of temperature. It's directly going to affect. Density inversely going to affect. Okay, humidity also is going to affect. Wind direction also is going to affect. Okay, these are the 5 factors affecting the sound wave. Okay, the next thing, reflection of the sound wave. So reflection of the sound wave. See, it's very simple explanation only. Laws of reflection. First we will do the laws of reflection. Laws of reflection. Imagine you are standing perpendicular to the wall. If you throw the ball, you can get that ball directly. Okay, when you are throwing the ball directly, it will come back to the same angle. Okay, so this is called normal. Okay, so the ball is thrown at incident angle and reflected angle normal lies in a same plane. Okay, in case imagine the same concept. Okay, the ball I throwed 30 degree from the normal. Just I throwed one ball 30 degree at the normal. The same 30 degree person can able to catch that particular ball. Okay, so it is 30 degree, it is 30 degree. So incident angle, it is reflected angle. Incident angle is equal to reflected angle. So the first law is saying normal, incident angle and reflected angle lies in the same plane. When we are perpendicularly, when we are speaking, so you are able to hear the sound back with the same angle. Okay, 0 degree. Okay, if you are able to, if you suppose you are talking with 60 degree to the wall, means the 30 degree from the wall, means the same 30 degree person able to hear properly. Okay, this what the law of reflection says. Okay, then sound have the refraction property also. That also I am going to explain how the sound have refraction property. So here I have the air bag filled with CO2, like a convex lens only. Okay, this is called air bag. Okay, here I have the candle. Okay, this is the experiment to prove the sound have the refraction also. Okay, so here it's a source of sound. I am producing the sound wave. Okay, so directly it's going like this. Sound wave is going like this. Okay, so when it is going with this bag, okay, it is a carbon dioxide bag. Okay, so it is look like a convex lens. Okay, so all the sound is going to focus at one particular point. Okay, when it is focusing, this burning candle is going to stop because of focusing of sound wave. Okay, using of this experiment we proved sound have refraction also. Okay, so this video we discussed properties of the sound, factors affecting the sound wave, reflection of the sound wave, refraction of the sound wave. Okay, if you like my channel, please subscribe my channel. Thank you for watching my video. It is this is a video, it's continuation of waves. Okay, then next video I will give a full content about the waves. Okay, it's for class level. Thank you for watching my video. Thank you everyone.